Welcome. Today we'll solve a challenging implicit differentiation problem step by step. Let's look at our question. Let's start by simplifying our equation. Taking the sign of both sides, we can rewrite this as sine of x plus y equals y over x. Now, we'll differentiate both sides with respect to x. On the left side, we use the chain rule. The derivative of sine is cosine, and we multiply by the derivative of the inner function. On the right side, we use the quotient rule. Next, let's differentiate x plus y. The derivative of x is 1, and the derivative of y is dy dx. So we get 1 plus dy dx inside the parentheses. To eliminate the fraction on the right side, let's multiply both sides by x squared. Now, let's distribute x squared cosine of x plus y across the terms in parentheses. Let's group all terms with dy dx on the left side and all other terms on the right side. Finally, we can solve for dy dx by dividing both sides by the coefficient of dy dx. This gives us our final answer. Dy dx equals y plus x squared cosine of x plus y, all divided by x minus x squared cosine of x plus y. This problem demonstrates the power of implicit differentiation and careful algebraic manipulation. Remember to take it step by step and always check your work.